Welcome back to Civic Minded. Today I've got this 2009 Odyssey radio in my electronics workstation here, my very messy electronics workstation. And I'm going to be showing you the circuit I built to, well, it works with the tape deck already, that's why I've got it, that's why I'm using it for this demo. But I'm going to show you the circuit that I built to actually control the tape deck. So once I've got it perfected and such, I'll put it in this little, this is just a PLA copy of it, but I'll put it into this enclosure here. You can see there are buttons. There's a slot for the eject button because it's actually built into the tape deck. And there are screw holes for the board, so I'll be doing that, and that's how I'm going to get my tape deck to work. But for now, I'll show you the control circuit. So here we've got a breadboard, obviously. The I/O expander that I showed you in, I think it was the last video. That is connected to these three LEDs, and this tiny screen, just the backlight, not the screen itself. The screen itself is coming later, I just don't have the board for it, but controlling the I/O expander is our old friend the Arduino Uno, and that is programmed to read the IEBus signals from the radio and tape deck and convert them into the appropriate light signals, or rather, light up the appropriate LEDs. So to start, I'm going to turn the radio on, and as you can see, the screen lit up. So the backlight of the screen is on now, nothing else is lit. If I press aux to switch to tape mode, the green LED comes on. That green LED indicates the noise reduction feature that you can see. NR, that's noise reduction. So I don't have a tape in there right now, but I'm going to switch back to FM. You'll see the LED turned off. And I'm going to load a tape. Look, the LED came back on. Now the tape is playing on the upper side A. I think that's side A, that's up. And obviously if I hit this, changes direction, noise reduction on off. You see the little Dolby logo turning on and off, and if I do the same thing, the LED also turns on and off. Then I can rewind and fast forward, and I'm going to demonstrate rewinding here because, and if I hit this button up here, no, this button down here, the rewinding stops. Hit this button, other LED came on, now it's fast forwarding. Now it's off. This one is noise reduction as well. And then if I hit this one, tape changes sides. Isn't that awesome? Hit it again, tape will change back to up. And if I hit the seek button on the Odyssey radio, and this will be done by the steering wheel audio controls in the final design, we start rewinding. We're going to rewind until we see the start of a song. I'll try to keep both the LED and the rewind logo in frame, or rewind text. There we go. That stopped rewinding, and now the tape is playing. Here's some footage I took of that feature working in the car when I built this circuit. There's no additional hardware required for it, it just clones the message from the steering wheel buttons, which is really coming from the iMid, and sends them to the tape deck so it rewinds or fast forwards in the song skip, music search mode. So these four buttons are going to be mapped to these four buttons here. Yeah, they're a little small. I'll work on that. This is not, like I said, this is just a test fit to make sure it fits on the tape deck, and it does. And this screen is going to go into this cutout here. Here's the tape door. And then each of these LEDs is going to be under its respective button. So if this is rewind, that's where this rewind LED is going to be, which just leaves us the problem of selecting the tape deck from the 9th gen radio, and I've taken care of that. So you may notice, I'll turn the radio back to FM here. Notice the LED turned off. I'll eject it. Ejected. And if I push the tape to load it, it switched to tape mode. So there's an IEBus signal that you saw in the first video that is sent by the tape deck when it's loaded. So if I was to, let's switch the radio off. See the screen turned off. That's been a bit buggy, so it may not come back on immediately, but if I hit the direction change button, it switches to the tape. And if I go to FM, the tape stops, hit direction change again, goes back to the tape in whatever direction it was playing, so that's kind of a double feature button. So when we want to switch to the tape deck from another audio source, we can just hit the direction button and it'll switch. Eventually, I want to have this screen displaying the status of the tape deck, and if another source is selected, the name of that source, so like CD, FM, XM. And when I make the completely custom radio, I think I'm gonna have one of these right below the screen, because they're just so damn cool. Oh, whoops. Well, cool, and yeah, the wire popped off, but we don't really need that right now, because like I said, it doesn't do anything. It just lights up. So we've got that. We've got rewind, fast forward. Those are all coming through the I/O expander. We can turn noise reduction on and off. You see that does follow with what's on screen. And yeah, that's pretty much it. Here's what that looks like with the cover on. Here's where our display will go, and the eject button. You can see the tactile push button inside the tape deck for that, and that's also where the backlight is. It's mostly okay. These are not mapped yet because there's no board, but there is some slight friction when I try to load a tape. But it does load, and it starts playing as normal. See that? And I'm going to turn the radio off. And yeah, next video I'll hopefully have the board for this made, or I'll have this working, one of the two. And I'll show you what that's like. Here's a schematic of my circuit. Or this is the final circuit, obviously, but it's more or less the same as what I had in the breadboard. So we're going to have a single connector that the front panel will plug into. And what's really cool about this tape deck is it has two different connectors for IEBus and audio, so I can just plug one of them into the car and plug the other into this front panel, which is essentially like a little remote control for it. Here we have power conversion. This is just sort of a pre-voltage regulator because the Arduino that's going to be controlling it, and I think all of the chips that are going to be running it are meant to run on low voltage, like 5 volts, and the LCD is actually meant to run on 3 volts. And that car battery is obviously 12 volts, so we gotta step it down. This is the first part of that. I like to call it the pre-regulator because essentially I found that these voltage regulators here just, well, they tend to not be happy if they're suddenly connected to higher voltage. I'm higher than 12, but certainly, it's just a precaution to keep that from happening. What this does, it essentially ramps up the voltage input at these voltage regulators to whatever the battery voltage is. The voltage regulators themselves are AP63301 switching voltage regulators. I've had very good luck with these. They're very efficient, holy crap. And the switching speed is fast enough that I don't need anything super large. 22 microhenries and 44 microfarads is nothing. You can fit this on... Hell, you could probably fit this on a breadboard the size of a thumbnail if you had to. But there's two of them, like I said. One of them is for 5 volts for the Arduino, or the chip, the microcontroller that will be programmed by the Arduino, and all of the other communication stuff, and 3 volts for the LCD. So that's that. Here's the microcontroller itself. This is the same chip that's on the Arduino, just a QFP version of it, so I'll show you what that looks like. Crap. If this opens... Sometimes that takes a while. There we go. So it's a more compact version that will fit in something the size of a tape deck panel. Oh, okay. It just jumped. But then we have our I/O expander. It's the same one you saw on the breadboard. Each input-output goes to either a button or an LED. This is just an off-page connector indicating that it's going to a different page. Got our oscillator. I found that this worked better with a resistor connected to ground for TX as well, so the sending IEBus signal, because the thing has to send IEBus. You see we got IETX and IERX. We're not only receiving IEBus signals from the radio and tape deck, we're also sending them for button controls and such. So this is a header, like a little basic Arduino header for programming. I'll get into more detail on this when I actually build the board. But moving on to the next page, this is where all the lights are. And I've got it set up, so you may have noticed that there are illumination wires coming in. Yes, this IEBus devices of this vintage actually do support illumination. So this tape deck, you saw next to the eject button, there are those lights. It can actually be backlit. So what I'm going to do is I'm going to have all the buttons backlit with the standard Honda white, and then illuminate them in yellow when the feature's active, but I'm also going to turn that backlight off if it's on. So let's say I'm driving, listening to a tape. It's nighttime. I'm going to have all my lights on, the illumination's on, all the buttons are going to be white. And if I want to start rewinding the tape, the white behind the rewind button is going to turn off and the yellow is going to turn on. And it's going to turn on at the same brightness as the white was, so that's pretty cool. Moving on to the LCD, it's literally just, it's the same SPI standard that the IO expander uses. It just needs to run at 3 volts. So we've got, these are called Zener diodes, and what they do is they essentially form a voltage divider with this resistor here, but they make it so that this output between cathode and anode is always 3 volts. So regardless of what's coming in here, we're always going to have 3 volts here, which is important. And lastly, we've got the IEBus transceiver. You remember me saying that IEBus is a differential signal? Well, we got the differential input and output that connect to the car and tape deck here. And that is read. I kind of did some experimenting when I first learned IEBus. The one thing about it is that it's a differential signal, but it's not always easy to read. You kind of have to amplify it before it can get read by a standard MCP 2551, which is what you use for sniffing the CAN bus, so just for example. So this circuit basically amplifies that. We have, what this does is it subtracts the differential signal here, and then this is just a basic non-inverting amplifier for the negative input signal, and that gets fed into a second 2551, where it gets outputted as the received signal, and then the transmitted signal that can just go out as normal. And this, what is this? This is voltage reference for the half a volt center that the IEBus nets are going to be at. But yeah, that's basically the circuit. Let me know if any of that needs clarifying, because I know there's a lot in there. But I think that's going to do it for now. Just a little quick update on where this project's going, and don't worry, we got other mod projects. I'm currently working on one that I'll be doing with Zach. That's, I think a lot of you are going to want to put in your cars if you can. But I guess for now, drive safe, have fun, and I will see you next time. Hell yeah.